Dear students, in this class I'm going to discuss with discrete mathematics. This is a university question, was coming in 2020 November December examination. One of the question is define a complete graph. What is a complete graph? This comes in unit number 3. Complete graph. What is a complete graph? Now look at that. So in a graph g of e comma e, if each pair of vertices is joined by an edge, it is called complete graph. Okay, look at this particular picture, or we can say graph here. Now suppose that this is vertex v1, this is vector v2, this is v3, this is v4, and this is v5, and this is v6. Now all these vertices are having edge between them. Any pair you take, this and this you take, it is having a edge. This and this have an edge. This vertex v6, v5 have an edge. v5 and v4 have an edge. v5 and v3 have an edge. v2, v6 have an edge. v1, v3 have an edge. Like that, if you take any two pair of vertices and they are connected by an edge, am I correct? So such a type of graph, we call it as a complete graph. Similarly, in this picture, you take that this is vertex A, this is vertex B, this is vertex C, this is vertex D, A, B, C, D, this is vertex E. Now what you are seeing here is that each and every two vertices are joined by an edge. C, AB is joined by an edge. BC joined by an edge. CD joined by an edge. ED joined by an edge. EC joined by an edge. EB joined by an edge. AC joined by an edge. AD joined by an edge. So each and every vertices, pair of vertices joined by an edge. Okay, am I correct? So such a type of graph, we call it as complete graph. Okay, so thank you very much. Okay, students, really happy to invite you to this wonderful discussion on the university questions. And in today's class, I would like to take some question from Anna University. Anna University appeared in 2020 November and December months. Now we are currently discussing about the unit number 3. Therefore I have to take 2 more questions in unit number 3 today. So this question already I have discussed with you. A complete graph is a graph in which each and every pair of the vertices are connected. Now I am taking the sixth question, that is, draw the graph with the following adjacency matrix. This is adjacency matrix, and for that we have to draw the graph For this matrix we have to draw graph. Right, so let us I take the blackboard. My blackboard is ready for the presentation. Okay, so what is the matrix given to us? 0 1 0 1 0 1 0 1 0. Okay, for which we have to draw the graph. Now what is the graph given to us? 0 1 0 1 0 1 0 1 0. So this is a matrix given to us, that is adjacent matrix for some graph. What is that graph? That is what the question here. Now look at that. The number of columns denote number of vertices. The same vertices we have to write in row wise also, right? Now so I write V1 corresponds to first column, V2 corresponds to second column, V3 corresponds to third column. Now V1 corresponds to first row, V2 denote the second row, and V3 we can take the third row. So this is what we say, adjacent matrix based on adjacency of the vertices. Now look at this inside the bracket. 0 1 comes. Whenever 0 comes, the intersection of the row and intersection of the column vertex are not adjacent to one another. I repeat, inside this matrix, if 0 comes, that implies there is no adjacency between the row vertex and the column vertex. On the other hand, if 1 comes, that means there exists an adjacency between the row vertex and the column vertex. Take for example here, 1 comes, implies this row vertex V1 is adjacent, that is very near, that is there exists an edge between V1 and V2. So V1 and V2 are adjacent to one another. So this matrix is called an adjacency matrix. If the vertex are near to one another, I mean adjacent to one another, 1 will come, and if they are not adjacent to one another, then 0 will come. So on the basis of that, we have to draw the graph for this matrix. Right, now how many vertices are there? V1, V2, V3. 3 vertices are necessary here to draw the graph connected to this matrix. Now so I am taking 2 vertices and I am calling it by V1 first vertex, V2 second vertex, and V3 third vertex. Now on the basis of the adjacency matrix, we must make the edge between the 2 adjacent vertices. Okay, now look at this, V1 and V1. Here 0 comes, so there is no adjacency between V1 and V1. V1 is itself, so there is no meaning for adjacency. But in some time there may be loop, so in that case we have to write one here. Okay, come here, 0 comes. That means this vertex V1 and this vertex V1, they are not adjacent to one another. They are not very near to one another. I mean there is no edge between V1 and V1. That's why we have 0 here. So we cannot draw edge between V1 and itself. Now come here. V1 and V2 are adjacent to one another. That's why 1 comes here. So 1 comes implies this and this are adjacent. I mean, there exists an edge between V1 and V2. So we have to draw an edge between V1 and V2. Now V1 and V3, they are not adjacent because 0 comes here. They are not adjacent. V1 is not adjacent to V3. That's why we have 0 here. So we should not join V1 and V3 by an edge because they are not adjacent to one another by this matrix idea. Now coming to V2 and V1, yes, 1 comes here, 1 comes here, look at that, 1 comes, which implies V1 and V2 and V1 are adjacent to one another. V1 and V2 or V2 and V1 are adjacent to one another. Therefore we have to draw a edge between V2 and V1. It is already drawn. It is already done. Okay, that's what we have to understand. Now look at that V2 now. V2 and V1 are adjacent to one another. So that's what we have drawn here. V2 and V2, no, they are not adjacent. V2 and V3, yes, 1 comes, they are adjacent to one another. Therefore we have to draw an edge between V2 and V3. Okay, then V3, V1, there is no adjacency. We should not draw an edge. V3, V2, yes, we have to draw an edge, and V3, V3, there is no edge. Okay. So this is the way we can draw a graph on the basis of this adjacency. And so if the graphs are given, we must be able to make the matrices, and if the adjacent matrices are given to us, we must be able to draw the graph corresponding to that. Okay, thank you.